So last week we talked about finding a z-score. We talked about normal distribution and how to do all of those things. Now we're going to look at what if that z-score is not an integer value. Okay? How do we use that to find a probability? That's what we're going to be looking at in this lesson. So here you'll see a portion of table A. This is the table that we attached at the beginning of the year whenever we first started doing our notebooks. On pages 8 and 9 we have the z table. This is just a portion of that. Okay? So you have the entire table in your notebook on page 8 and page 9. Page 8 is the negative z-scores, page 9 is the positive z-scores. So you have this section in your notebook. So what we're going to do, you may want to have your notebook open to those because we're going to be using those probabilities to do these as examples. So if you're going to open your notebook, pages 8 and 9 should be where you can see them both at the same time. Page 8 and 9. You'll see this that's on here is the top part of page 8. Okay? Now, you'll notice whenever you look at these, the shaded part is to the left on both of these. The values in the table are always values less than. Okay? So if you're looking for something greater than, you're going to have to use what we call the complement rule. So if I was using this z-score and I looked it up on the table, it's going to give me this probability. Well, I know the entire area under the curve is 1, so if I wanted to know this unshaded part, I would just see 1 minus this part. So anytime you're looking for an upper range, if you're looking for shading to the right, you do 1 minus what's in the table. Okay? So, I don't know if you want to make a note over here or something, but remember, the only time you subtract from 1, because people start subtracting from 1 at various times, the only time you subtract from 1 is if it's shaded to the right. Anything shaded to the right, subtract from 1. So, now we're going to look at, on our notes, it says use the z-table on the formula sheet to find the probabilities below. So, here's what this is going to look like. Our z-score in the center is 0. Then to the right are the positives. To the left are the negatives. So those are our basic z-tables for any normal distribution. That's how we would sketch it. So if we're looking at a z-value of negative 0.75, it's going to be between 0 and 1, a little closer to negative 1. So I'm going to draw that right in there. And if I want it less than, it's going to be shaded to the left. So I'm just going to shade in over here on the left side. So then, if I want to know the probability Z is less than negative 0.75, I'm just going to look on the table. It's a negative, so I'm going to look on page 8. And along the left side is any whole number part and first decimal place. So if I'm looking for negative 0.7, it's going to be here. And then you'll notice along the top is the second decimal place. So I'm going to go over to 0.05, and then I'm going to see where those intersect. So that's going to be right down here. Okay, so this is the 0.05 column, and I'm going to look at the 0.7, and that's going to give me a value of 0.2578. Right? No, wait, that's in the wrong one. 0.2266. Sorry. Okay. So that is my probability. So that's how I get to that value.
We always have the right to use
This, yep, that's considered showing your work or using correct notation. Okay, are we good with that one? Makes sense. On the next one, we want a z greater than 1.5. I'm going to label along the axis, and positive 1.5 is going to be right about here. And now I want a greater than, so I'm going to shade to the right. So the probability z is less than 1.5. I can find that on the table. So I'm going to go to page 9 with my positive values. I'm going to look at 1.50. So that's going to be right here, 0.9332. So to get this shaded part, I just do 1 minus that. And that's going to, because that 0.9332 is all of this to the left, I want the part to the right, so I subtract it from 1. Probability z is greater than 1.5 equal to 0.0668. Questions on that one? Seem okay?
Yep. Why do you use table 9 or shades like that?
Table on page 9 is all the positive z-scores. We use that one because this was a positive 1.5.
So that graph on the top of the 9 shades.
No, it's just showing it shades to the left.
Okay.
Yep. Good question. Yes. Good question. Okay. I'm going to show you a different way of doing this one because some people like this other method better. And personally, this is the one that I usually use. Remember how we talked about the normal distribution is perfectly symmetrical. And we talked about that, it's like perfectly symmetrical. So that means if I wanted to know the probability of it being greater than 1.5, that is equal to the probability of it being less than negative 1.5. Okay? The area over here is the same as the area over here. So I could have looked at the probability z is less than negative 1.5, and that's the same as this. If you look up negative 1.5 on your z table on page 8, you get 0.0668. It's the same. So if it makes more sense to you, if you're shading to the right, to go to the negative of that z-score and look at that, that's one way of doing it, because it is perfectly symmetrical. The area on this side is the same as the area on that side. Okay, let's look at part C. So here we have we're going to look at negative 2.13, so about right here. Oh. Didn't mean to do that. And then 0.54, so about right here. But you know I didn't shade that. I didn't mean to do that. And we're looking at z is between those. So I want all of these values in here. So between this one and that one. So when we do this, I can look on the z table and I can find the area from here all the way to the left, and I can find from here all the way to the left. So what I'm going to do is I'm going to find this one and then subtract this area down here that wasn't shaded in between. Okay? So z less than 0.54, I can look up this on page 9 on the positive z-scores. 0.54 is 0.7054. Then I can look at the probability z is less than negative 2.13. It's going to be over here on the other page. I'm taking from here over and subtracting this little piece on the tail that would not be shaded. So I'm just subtracting those. .6888. So anytime you're looking for between, you do the one on the right and then subtract the one on the left. And that will give you value between. You okay with that one? Questions so far? Let's look at D. Okay, so we've got z less than negative 1.4, so about right here. Over there. Or z is greater than 2.05. Over here. So we got this piece or this piece. So we're going to find the probability for each one and then add them together. So if we want probability z is less than negative 1.4, we're just going to look on our z table at negative 1.4, and that's going to be 0.0808. And for this one, since this one is shaded to the right, we're going to do 1 minus whatever the probability is on the z table for positive 2.05. So 2.05, 0.9798. So to find that combined probability, you just add those together. Questions up to this point? Okay, so let's look at the inside. Okay, so here we're talking about Miss Temple and her pet ferrets. So she has 2 adult ferrets, Shiloh and Bellatrix. They have a mean length of 14 inches and standard deviation of 0.9 inches. Okay, so we're going to use that information. So our mean is 14 inches, standard deviation is 0.9 inches. Okay, so we're going to say that is true for the entire population of adult female ferrets. So we need to know what is the probability that a randomly selected Jill or female ferret is less than 15 inches in length. So when we go to sketch this situation, that mean goes right in the middle. And then we use the standard deviation to label each direction. This will be 15.9. So the 15 inches is going to be right in here. You guys see that? I have to write really tiny. So 14, 14.9, 15.8. This is the first 3 standard deviations. You want to label enough that it shows where this point that we're talking about here, this 15 inches, we want to show where that fits. So it's just a little past the first standard deviation. And we want it to be less than. Since I said less than, we're going to shade to the left. Okay. So far okay? Alright. Next we want to find a z-score. So z equals the value we're looking at, 15, minus the mean, which was 14, divided by standard deviation, 0.9. And we always round to 2 decimal places because that's what our table shows us. Our table only shows us where we can look up for 2 decimal places, so that's where we round. Then we want to look on our table, so we're going to look on the positive one, so page 9. Look up 1.11. So 0.8665. Then we're just going to write the answer in context, and I always go back up and see it says what is, and then it says the probability that a randomly selected, all of this, that is my answer in context. So I write that exact same thing. So that all just came straight from the question. Okay, it's the underlined part of the question. I just write it down here. And then I just say is, and then whatever I found is my probability, 0.8665. And that's it. So if you go back and look at how is the question asked, that's your context you want to use to write your answer in context. Alright, part B. We want to know what's the probability that a randomly selected Jill is longer than 13.3 inches. So 14 is here in the middle. we subtract 0.9, we're at 13.1, so it's going to be just a little bit below that, or no, 13.3, a little bit above that. So right about there. And this time we want it longer than, so we're going to shade on the right side. I'm going to show finding the z-score, so anytime you do a calculation, please show it on your paper. You have to show those things to get full points. So the value is 13.3 minus the mean, which was 14, divided by standard deviation, which was 0.9. We're down to 2 decimal places, so we get negative 0.78. Then we want to look this up on the table. And since it's shaded to the right, we're going to do 1 minus whatever we find on the table. So negative 0.78 would be 0.2177. Subtract that from 1, I get 0.7823. And to write the answer in context, I go back and see what did the question say. So all of this is my context for that answer. Yep, you're right. See? Okay. Does this seem okay? Does these make sense to you? Starting to, at least. Okay. So part C, we're going to between. So what's the probability that it's going to be between 12.5 and 14.5 inches in length? So I'm going to label these values. This is my 14 in the middle. 14.5 is right in between there. And then 14.1, 12.2, so it's going to be in between there. So I'm shading in between these lines. So now when I'm calculating finding the z-score, I need to show both of them. Okay, I'm going to find a z-score for the 12.5 and a z-score for the 14.5. of a z value between those. So to do that, I'm going to look up this z value, find that probability, find this probability, and subtract them. So I always do the one on the right minus the one on the left, so I end up with a positive value. You should always get a positive number for your probability. So I'm going to look up the 0.56. And then I'll look up the negative 1.67. Go back to the question to get my context. So all of this is my context statement. Okay, so I'm going to give each table a practice problem. There are 4 of these, so once you finish, try with another table, and this is going to go on the other page of your notes. Okay.